and they turn into rocks.
I had my finger out the whole time and it wasn't recording.
The more that rocks are buried under time, the older ones are below and the younger ones are on the top because it's over time. Remember, as I built my sandwich, I put something on first, and then I put the turkey on, and then I put something on. It was built over time. See how these are folded? Those are called folds. Sometimes the earth shifts and moves. There might be something that lands on one side but not the other, just like my tomatoes. That's called the principle of superposition. Older on the bottom, younger on the top. So when we have these layers, we've been talking in class about what's horizontal, what's vertical. Our lines that are sedimentary are formed originally horizontally in layers, just like my ham and my turkey and my cheese. When we study these, the problem is we can't see them. We live on the top layer. If you look at my sandwich, what do you see? You see bread. You don't see all of the cool stuff. In a future lesson, we'll be taking cupcakes and we'll be drilling some core holes. And this is what a scientist's core looks like. If you see all of the different layers, those are the sedimentary layers that are taken from a core sample. So, and this I thought is just a really neat picture. Notice how they're not like this. They're kind of tilted. We'll be talking about how Rocky Mountains have kind of tilted, how the earth is rusting up. I just thought it was a really cool picture, so I had to put it in there. The vocabulary that we need to understand is when we're looking at my sandwich. My sandwich isn't completely even. There's tomatoes on one side. So I've got, and that is called dip, the angle. And the strike is the line across. And this is a good map. And we're going to keep this map up when we do our project that we're going to do, because I'm going to need you to be labeling dip, strike, and strata. The lines are the strata. So someone give me a thumbs up, tell me you understand each of our three terms, because you're going to need to label your model with these three terms that you're building later today. Most excellent. Thank you. So these are samples of sedimentary rocks. These aren't big, huge formations like my other pictures. These are shorter, just smaller little rocks. And I'll have some samples that you'll be able to look at. Oh, and you'll see that these rocks all have lines. You can tell that they've been compacted and built into these. There's some others that aren't up here. There's some schists and some mica schists. Shale is one. Some of them even come apart, flake. And this is just another really cool example here in our country of where you can see sedimentary rock samples. So there's a neat thing that we're all going to be looking at. This is from the NSTA website. This is an article about a fourth grade class that discovered they would live in Lake Ontario. There's a lot of snow in Lake Ontario. So what happens is they were able to do a study of sedimentary rocks and or sedimentary formations. I'm trying to get to the picture. Come on, Pokey, come on. We'll all have copies of this article up on our computers, because then we will be doing summaries of this in our notebooks. I'm trying to get to a picture here. Look at this picture of the snowbank. Can you see? This is the older, and they can tell what is happening in the snow based on the layers. The snow first, cars went by, they shoveled it. This is newer snow. By the dirt and the layers of the rocks, this is an example of sedimentation. So, and that's from the NSTA website. So, the project we're doing today is we're going to be making models using some Play-Doh, and you'll each have, working in teams, you'll each have about 6 colors of Play-Doh, some clear tubs so that you can make something similar to my sandwich in a clear tub so you'll be able to see a cross-section. I've got a rubric created so that you can follow along and look and see what are my expectations for my model. I expect to see some angles in my model. I expect there to be some use of different colors, some stratification in your model, and then you'll be drawing in your scientific notebooks copies of your model correctly labeled with dip, strike, strata, and I also want the definitions for the principle of horizontality and the other one that just completely went superposition. So this is where I take this lesson, and Jess isn't here, and you say, "What an extra minute for this." And Jess was supposed to do metamorphic rock, and he's not here. So what I'm going to do to show you quickly how to make a metamorphic rock out of a sedimentary rock, I'm going to take my sandwich. Remember my grill that I didn't plug it in, right? So there was no heat. I just smushed my sandwich. My grill is now on.
I can smell it.
I am now grilling this sandwich. When that sandwich comes out, someone tell me what the difference is going to be in what my sandwich looks like.
The cheese will be melted.
Cheese is going to be melted.
Bread will be brown.
It's going to be brown. What else is going to happen in my sandwich?
Tomatoes going to be gushy.
Exactly. My tomato's going to be gushy. The process that's happening to my sandwich is very similar to the process between sedimentary rocks and metamorphic rocks in that heat is applied. As the rocks are moved closer to the Earth's core, heat and pressure change our rocks into a full different type of rock, which is metamorphic. Hence, I've added a second demo to my original demo, and who wants a sandwich? Yeah? Who wants? Seriously, I just made a sandwich. No, I'm turning it off.
Turn it off?
Yeah, turn it off.
Oh. How do I stop this thing? Stop. I'll just turn